Hey everybody, welcome to Geometry, Section 3.5, Parallel Lines and Triangles. This is a lesson I kind of like. I'm very much a puzzle guy, and so I like being able to figure out puzzles. And in this lesson, we're going to figure out a few things that'll help us figure out geometric puzzles. So by the end of this lesson, you should be able to understand and use the triangle sum theorem. You should also be able to use ratios and the triangle sum theorem to figure out missing angles. And lastly, you should be able to understand and use the exterior angle theorem. So let's talk about the triangle sum theorem. Hopefully you already know this, but if you take all three angles in a triangle and add them up, you get 180 degrees. So just to kind of give you an insight on how people discovered that, if we take a look at this diagram, and you also might ask, why are we talking about this in the middle of parallel lines? Because in order to figure this out, mathematicians back in the day, they drew a parallel line to one of the sides of the triangle. So here you can see that line AD is parallel to side CB. So here I've got angles 4, 3, and 5, and since they make a straight line, we know they add up to 180. So if we take that idea, 4, 3, and 5 add up to 180, we also know that angles 4 and angle 1 are alternate interior angles. So you know that they're congruent. So what I can do now is I can take that fact that angle 1 is equal to angle 4, and I can kind of substitute it into that equation. So now I've got angle 1 plus angle 3 plus angle 5 equals 180. If we take a look at the other side of the diagram, angle 5 and angle 2, those are also alternate interior angles. So because angles 5 and 2 are the same, I can plug that into the equation, and where angle 5 was, I can change that to angle 2. So now I know that angles 1, 2, and 3 add up to 180, which is where we get the idea that all three angles in a triangle will always add up to 180. So let's go ahead and take a look at a few examples on this. So here we have a few examples. Let's take a look at it. Some of them might be very easy, like they give you two of the angles, figure out the third one. So technically you could go 47 plus 58 plus x equals 180. Add those two things together, and we're looking at 105 plus x equals 180. Subtract the 105, and you get 75. It also might be a little bit more complicated than that. We could have something kind of like what we have over here, where there's not just x, but there's an expression for that angle. So I can say 3x minus 1 plus 31. And I almost left out that one angle because there's not a number there for it, but it's 90. That little box tells us that. So those three angles all together add up to 180. Combine our like terms. So negative 1 plus 31 plus 90 is 120. And then just work our algebra magic from there. Subtract the 120 and divide by 3. So I get that x equals 20. Okay? Let's try another example. That gets a little bit trickier. But still going to do the same process. Add up all three angles, and they equal 180. So 3x minus 17 plus x plus 40 plus 2x minus 5 equals 180. Combine your like terms. So 3x, x, and 2x make 6x. Negative 17, positive 40, that's what, 23 right there. And then minus 5, that gives you positive 18. Subtract the 18. Divide by 6. And what are we looking at here? So, and then 42, so 27. So x equals 27. Now be careful, make sure you're watching what they're asking for. In this case, they're just asking for what x is. However, they might ask you to figure out what the angles are, in which case you got to take that 27 and plug it back in. So 27 plus 40 is 67. 2 times x, 2 times 27 is 54. 54 minus 5 is 49. 3 times x, that's going to be 81. And 81 minus 17 is going to be 71, so 64. Okay, so always be on the lookout for what they're asking for. Sometimes they can also be a little bit trickier. So for instance, we're trying to figure out what x is over here on this equation, or this diagram, but there's nothing but variables over here and nothing for that missing angle. So what I have to do, this is where that whole puzzle idea comes into place. I got to use the other clues around to figure out what the variable is. So what I can do is I can say, well, these two angles, I can add those up and subtract that from 180 and figure out what this missing angle is. So I'll go ahead and do that. 57 plus 43, that's 100. And so then 100 minus, or from 180 is 80. Well, we should know from previous lessons that if that angle is 80, this angle is 80 because they're vertical angles. And so I should know that x plus 80 equals 180. Subtract the 80, and I get 2x equals 100. Divide by 2, and I get x equals 50. All right, so not as straightforward as the previous examples, but it is kind of like a puzzle. Let's take a look at this other puzzle over here. Here it looks like I've got 2 overlapping triangles, which make a third triangle. And oh, this is all sorts of complicated. So what I'm going to do is I'm going to take a look at this outlined triangle. All right, so this angle up here is 65. This angle down here is 90 degrees. So if I add those up and subtract it from 180, I should get that this angle down here is 25 degrees. Okay, can I figure out what x is yet? Not quite. Then I can go ahead and take this other triangle. And I can say, all right, so actually, I'm not even going to do that. I'm going to take this triangle and say that if those two add up to be 130, subtract that from 180, and we're looking at 50 degrees right here. Well, hey, I didn't even need to figure out that 25. I can figure that x is 130 because that 50 degrees and that x are a linear pair. So I kind of thought I was going to go one way with this puzzle, but in the middle of all my calculations, I figured out there's an easier way. So I didn't even need that 25. All I needed to know was that the 3 angles add up to 180, and then I've got a linear pair between these 2 angles. Okay? So that's kind of fun for me, is trying to figure out missing things and trying different approaches and maybe switching up your line of thought in the middle of it. So kind of fun. Last thing I want to do with the triangle sum theorem, you might get a question like this. It says the 3 angles in a triangle form a ratio of 2 to 5 to 8. Find the measure of the largest angle. So what that means is there's 3 angles, and when you compare them, there's a scale factor that if you reduce that scale factor, you get the ratio of 2 to 5 to 8. So here's how I'm going to do this. I'm going to say that F represents the scale factor. And so then I'm going to write an expression for each angle. So 2 times the scale factor, 5 times the scale factor, and 8 times the scale factor. So those expressions represent all three angles in the triangle. And I should know that all three of those angles have to add up to 180. So then 2 plus 5 plus 8, that gives me 15. Divide both sides by 15, and I think we're going to get 12 on that. So that means our scale factor is 12. So that's not the final answer because it's asking us to find the largest angle. What I have to do is I have to go back to that ratio and multiply each of those things by 12. So 2 times 12 is 24 degrees. 5 times 12 is 60 degrees. And 8 times 12 is 96 degrees. So those are the actual measurements of the three angles, as 24 to 60 to 96. And if you were to reduce that, then it would come down to 2 times 5, 2, 5, and 8. So what's the measure of the largest angle? 96 degrees. Let's do one more like that. So I'm going to do the same thing. I'll take 3 times the scale factor, 4 times the scale factor, and 5 times the scale factor. Add them all up and set them equal to 180. So 3 plus 4, so we're looking at 12F. Divide both sides by 12, and I get that the scale factor is 15. Go back to that ratio, multiply each of those by the scale factor. So 3 times 15 is 45. 4 times 15 is 60. And 5 times 15 is 75. So the largest angle is 75 degrees. So that's the angle sum theorem. And hopefully that's a pretty doable concept. So let's go back to the idea of the exterior angle theorem.